Alright, now I just had dinner and now I'm recording the second video of the second week. So in the previous video I talked about Pareto set. So with the CRS technology, Pareto set is below or above or totally overlapped with the diagonal of the edge of the box. So Pareto set is related to the notion on the next slide, pro-auction possibility set. So I think you guys ever seen this pro-auction possibility set in principal class. So the set depicts the set of pairs of outputs which can be produced with the available factors in the economy. Right, so the set is right here. Yeah, right here. So any output pair in this set can be produced with the available factors in the economy, right? So I think you guys have a good understanding about this notion. And its boundary is called a pro-auction possibility frontier, in short PPF. So if an output pair will be on the front is on the frontier, that means the pro-auction runs efficiently. So think about point A. So here there is no way to increase output 1 without decreasing output 2. So that is consistent with the notion of Pareto efficiency. So in this sense, pro-auction is efficient. So in other words, a factor is allocated efficiently. So the factor allocation lies in the Pareto set. Right? So that is related to Pareto set in the attribute box. And one thing important regarding this PPF or Pareto set is if the pro-auction technology exhibits decreasing marginal productivity, so if the pro-auction function is concave with respect to each factor, then we can show that PPS is a convex set as displayed, in this diagram. So convex set means if we choose any points in the set, so this pair and this pair, so those two plans, those two output pairs are feasible in this economy, so can be produced with the available factors. Then any line segment, so linear combination with these two plans, there's a line segment. So any output pair on this line segment are also feasible. Okay. So using concavity of pro-auction function, meaning that f of lambda z1 plus 1 minus lambda z2 is higher than lambda f of z1 plus 1 minus lambda f of z2. That is a definition of concavity, concave function. So using this, it can be shown that PPS is a convex set. So this is quite straightforward. It's not a difficult proof. So let me leave this for an exercise. Okay? And instead, let me focus on factor intensity. So we are going to make one more assumption for simplification of our analysis. So the assumption is, so we're going to assume the pro-auction of a good 1 depends on factor 1 more than pro-auction of a good 2. Okay. So how to formalize this idea? If we have two inputs, labor and capital, one production is more intensive in labor or more intensive in capital. How to formalize this idea with the CRS technology? So here's a definition. So firm 1 is relatively more intensive in factor 1 than firm 2 if the following inequality holds. So in this inequality, we have the ratio of factor uses by firm 1. So A sub 1, 1. Firm 1's demand for factor 1 when target quantity is given by 1. So that is a conditional factor demand function of firm 1. A sub 2, 1. The firm 1's use of factor 2, right? Conditional on target quantity being equal to 1. Okay. So this is a ratio of factor uses by firm 1. And similarly, we have a ratio of factor uses by firm 2 on the right-hand side. So the left-hand side is always larger than right-hand side, regardless of prices. So then, we can say firm 1's production depends on factor 1 a little bit more than firm 2, right? So that is factor intensity definition. Right? So one thing we have to notice is, for factor intensity, this inequality should be held at all factor prices. Okay? So this is a little bit restrictive assumption because in the real world, depending on input prices, sometimes firm 1 is more intensive in factor 1, and firm 2 is more intensive in factor 1 at the different prices. But factor intensity requires firm 1 be more intensive in factor 1 at all factor prices. So there's a little bit restrictive assumption. But with this assumption, we can greatly simplify our analysis. Let me show how we can do that. Okay. So now, how do we analyze equilibrium in this economy? So first, this has nothing to do with factor intensity assumption. It comes from CRS technology. So first we can notice is with the CRS technology, equilibrium conditions are these two. Okay. So the first, the C sub 1, so the first firm's unit cost function should be equal to its output price. And firm 2's unit cost function should be equal to P2. Let me explain why this is true, because think about, so when analyzing firm's behavior using a cost minimization problem, the second stage was a determination of target quantity. What is the optimal target quantity? So what is the optimal target quantity, say, for the firm? And we now have to solve, we now face this problem. Maximization over Q, P times Q, minus cost function. Okay? But with the CRS technology, we know this cost function is linear with respect to Q. Okay? Meaning that we can rewrite this expression as PQ minus Q times unit cost. Okay? Then we can factor out Q, P minus C, unit cost of, so let me write unit cost by dropping off this number 1, just the C of W1 and W2, so function of input prices. You can now think about the determination of optimal quantity that maximizes this profit. If price is higher than unit cost, then with this CRS technology, the firm's optimal quantity is going to be infinite, right? And if the other way, so if now cost is larger than, so higher than price, then this firm will optimally shut down the process, production process. So it does not produce at all. Q is equal to 0. That is optimal quantity, right? It can be regarded as an equilibrium. I mean, this is an economy with a limited total endowment. So even though P is higher than C, firm can produce infinitely many units, right? And if C is higher than P in equilibrium, so no firms produce, then that is not an equilibrium either, because then we can anticipate input prices are, fall, right? Very close to 0. And no firms employ, any inputs. That's not an equilibrium. That's not, what happens in equilibrium. So in equilibrium, the only candidate for equilibrium is price should be equal to unit cost. Okay, so that is this is one more consequence we can derive from CRS technology. Right. So we have two equilibrium conditions C1 should be equal to P1, and C2 should be equal to P2. So we have two equations and two unknowns, W1 and W2. So we can identify input prices, equilibrium input prices from this system of equations. Okay. Once again, it is not related to factor intensity. Right? So what is the law of this assumption, factor intensity? That is used, now this assumption is used to show that this is linear, so this system of equation has a unique solution. Okay, so there is a unique pair of input prices satisfying these equations at the same time, simultaneously. All right, so first let me draw the diagrams displaying these equilibrium conditions. So the first equation is it can be seen as one level curve because the unit cost is given by P1. Okay, so putting first input price on the horizontal axis and the second on the vertical axis, we can draw a level curve. Okay, and similarly, we can draw the second equation as a from 2's level curve. So the from 2's unit cost is set by, so it's fixed by P2. All right, and now think about the level curves equation. So in the next page, say, all right, so C1, W1, W2 is given by P1, the first equilibrium condition. And in order to find the equation of the level curve, we need to totally differentiate this equation. So derivative with respect to W1 times differential of W1 and plus derivative with respect to W2 and W2's differential. Okay, that is total differential of the left-hand side of this unit cost function. And the right side is fixed by a constant, so that is 0. Okay, and the way to find the slope of the level curve is the same as the way to find marginal rate of substitution in consumer theory. Okay, so the dW2 over dW1, that is going to be negative C1 W1 and derivative with respect to W2. Right? Now what is the top? By Shepard-Lemma, we know this is a conditional factor demand function, so A sub 1, 1. Right? Because a target quantity is given was fixed by 1. And bottom is a sub 2, 1. Right? And similarly, the level curve of the second firm's unit cost function is a sub negative a sub 2, 1 over a sub 2, 2. Okay? So factor intensity, let me go to a definition. This ratio is always higher than, so it takes a larger value than this ratio. Okay? So this means, so this is the slope of the level curve of firm 1, and this is the level curve of firm 2. So we know that now we can find that. So now we can see that the firm 1's level curve is steeper than firm 2's. Okay, as is displayed in this diagram. Okay, so the firm 1's level curve is steeper than firm 2's level curve. So if they have an intersection right here, then there is no more intersections, right? And the solution to this system of equation is nothing but intersection of two level curves, right? And then two level curves can at most one intersection. So that establishes the uniqueness of equilibrium, input prices equilibrium. All right, so factor intensity assumption implies that two-level curves can cross at most once. So it is often called single crossing condition in economics, and that establishes uniqueness of equilibrium. All right. And one more thing we have to notice is, so input prices ratio. So the equilibrium price in general equilibrium usually determined by market clearing condition. In pure exchange economy, the relative price, equilibrium relative price was determined by one of the market clearing condition, right? In Robinson Crusoe economy, also determined by market clearing condition. But in this 2x2 production economy, armed with CRS technology, equilibrium price is not determined by market clearing, but determined by equilibrium condition, right? Profit maximization condition itself. That is one important implication. So equilibrium is defined as input prices and the factor allocation. Then the input prices are coming from these two conditions. So that is done, right? And we show the uniqueness and existence. That comes from this factor intensity assumption. And now the thing is, how do you determine factor allocation? Okay? So now once we identify W star, then we know this ratio. Okay? So that from 1, we'll choose a pair of factors along this ray. Okay? So with this ratio from 1 demands each factor. Okay? So the optimal factor allocation, so profit maximizing factor allocation from 1 should be on this ray. Okay? And similarly, from 2, given this equilibrium input prices, now we know the optimal ratio from 2 that maximizes profit. That is this ray. Okay? Because now we have to use this origin for the analysis of from 2's behavior, I mean optimal demand function. Okay, so they are going to meet a point in the attribute box, and that is a equilibrium factor allocation. All right. So although this is just a single point in attribute box, it has two different coordinates. Using this coordinate O1, and its coordinate is so Z11 star and Z2 Z21 star, and using different origin O2, the coordinate of this point is so this is a Z12 star, and this is a Z22 star, right? So two rays from two different origins determine one single point in the attribute box, and that's going to be equilibrium factor allocation. All right, so this is the way to find equilibrium in 2x2 economy. So let me summarize our discussion so far with this example. So 2x2 production economy with Cobb-Douglas production technologies. So two firms' production functions are given by Cobb-Douglas and different weights. So from 1 has a weight 2/3 on factor 1 and 1/3 on factor 2. And from 2, on the other hand, puts a weight 1/3 on factor 1 and 2/3 on factor 2. So with these different weights, we know we can infer from 1's production is more intensive in factor 1. Right? Factor 1 is more important in the production of good 1 than in the production of good 2. Okay? And price factor is given by P, that is a 1,1 unit vector for simple analysis. And still, it entails a heavy computation you're going to see why. And the total factor endowments factor is given by Z1 bar and Z2 bar. And now we are asked to find equilibrium factor allocations and equilibrium factor prices. All right, and how do we do this? So let me open a new note. So first, let me tackle on for one's behavior, okay? For one's cost minimization problem, because we need A sub 1, 1 and A sub 2, 1, okay? So conditional factor demand function, conditional on single output, single unit of output, and A sub 1, 2 and A sub 2, 2, okay? For firm 2. Okay, so for one's minimization problem, cost minimization problem can be written this way: W1, Z11, or A sub 11, whatever, and W sub 2, C sub 21, subject to, so firm 1's technology is Z11 to the power 2/3 times Z21 to the power 1/3. And this is a CRS technology. So we can set the target quantity equal to 1. All right. And the solution to this problem gives us A sub 1, 1 and A sub 2, 1. All right. Now, how do we solve this? Let me use the Lagrangian method. So set up the Lagrangian L, curly L. So W1, Z11, W2, Z21, and minus lambda, and lambda stands for the Lagrangian multiplier associated with this constraint. So Z11 2/3 and Z21 1/3 minus 1. Okay? Because this is a minimization problem, I put negative sign in front of the multiplier. If it was a maximization, then we put positive sign. Okay? And these different signs guarantee that Lagrangian multiplier is always positive. Okay? It's a non-negative value. Okay? All right, and the first condition. So first of the condition with respect to Z111. So we need to find out these two. So these two choice variables. So W1 minus lambda 2/3 Z11 to the power negative 1/3 and 1/3 and set it equal to 0. And with respect to 2, 1, now W2 minus lambda 1/3 2/3 and Z21 to the power negative 2/3 and set it equal to 0. Right? So from either condition, suppose that lambda is equal to 0. Then this term goes away. Okay? So from the first condition says W1 input price is equal to 0. That does not make any sense. Right? So in equilibrium, lambda should be positive. Okay, so from either condition, we know lambda is positive. Okay, what does it mean? By the Kuhn-Tucker theorem, if the multiplier is strictly positive, we know that its associated constraint should be binding. Okay, that is a complementary slackness condition. So by the complementary slackness condition, okay, positive multiplier means constraint. This inequality constraint should be held with equality, right? That means this constraint is binding. So Z11 2/3 and Z21 1/3, and it should be equal to 1. Okay. So we have three equations. Let me call the first equation number 1, and second equation number 2, and this one equation number 3. Okay, we have three equations. All right, and the way to find z sub 1, 1, I think you're familiar with this, but let me just show you one exercise. I'm not going to do this anymore any longer. So find the ratio. Okay. So divide the first equation by second. Then we have this lead us to W1 over W2, because now we know lambda is positive, so these two canceled out, right? And if we set the ratio and rearranging terms, then we get 2. All right, 2 times z21 over z11. Okay, from this, we can obtain expression of z11. So z11 is 2z21 times w2 over w1. Okay. So solving for z11, we get a expression of z11 as a function of z21. So now I can substitute this expression into the third equation. Okay. And substituting into equation number 3, then we have 2z1, z21, w2 over w1 to the power 2/3. Yeah, it's complicated, right? And z21, 1/3 is equal to 1. Okay, but fortunately, z21's power, because by the law of exponents, multiplication becomes addition. So adding two powers give us just a z21. So z21 is z21 times 2w2 over w1 power 2/3 is equal to 1. Okay, so z21 is 2w2 over w1 power negative 2/3, because negative power implies the reciprocal. All right. So, or w1 over 2w2 power 2/3. Okay. That's quite intuitive, because this is from 1's demand for factor 2, and the demand is decreasing over w2, right, and increasing over w1, meaning that the two inputs are substitutes. Okay. All right, so after finding z21, then we can obtain z11 from here. Okay. So that is, I already computed the formula. So z11 is 2w2 over w1 to the power 1/3. Okay. So because we set the target quantity equal to 1, okay, so this is nothing but a sub 21. This is the same as a sub 21, and this is a sub 11, because a stands for conditional demand. So factor demand conditional on q is equal to 1 when target quantity is given by 1. All right. Okay, then now we are ready to write the unit cost function. The first one's unit cost is W1, A sub 11, demand for factor 1, and W2 times W21. Oh, sorry, A sub 21. All right. So if you compute this and arranging terms, then you'll get W1 to the power 2/3 and W2 to the power 1/3. And where is the right? 3 over cubing root of 4. Okay. And you can do the same job, but now you may want to use symmetry because from 2's to solve a from 2's problem. Okay? And from the only difference is now from 2, put the weight 1/3 on factor 1 and 2/3 on factor 2. Okay. So A sub 1, 2 from 2's demand for factor 1 is W2 over 2W1 power 2/3, and A sub 2 is 2W1 divided by W2 1/3. Okay. It's consistent with orientation because this is a from 2's demand for factor 1. Okay, there's a decreasing function of W1, and demand for factor 2 also decreasing over W2, its own price, right? So by my reckoning, hopefully this is right, but please do yourself, and if you find some errors, don't hesitate to let me know, okay? And with this too, we can compute from 2's unit cost function. So W1 A sub 1, 2, W2 A sub 2, 2. Yeah, I mean, double scripts are always confusing. And remember, the second subscript is a firm's index. So this is a firm 2's demand. And the first subscript is a factor. So factor of demand for factor 1 and demand for factor 2. All right, and this is going to be, where is the, so W1 to the power 1/3, W2 2/3, and 3 over cubing root of 4. Okay, so now we found a unit cost function for each firm. All right, so once again, because the output price is given by 1 for each good, for both good, right? So in equilibrium, unit cost should be equal to output price. In case of CRS technology, otherwise, firm will produce infinitely many units, or will be shut down. So we set this C1 equal to 1 and C2 equal to 1. All right, and with these two equations, let me divide C1 over C2. Then we obtain, because these two are cancelled, and the right-hand side, 1 over 1, so that should be equal to 1. So W1, W1 1/3, and W2 negative 1/3. Am I right? So that is equal to 1. So from this, because W1 and W2 are positive, should be positive. So we obtain W1 and W2 should be equal to each other. All right, and plug back into any unit cost function. So because W1 turns out to be equal to W2, and solving this equation, then you obtain the equilibrium input prices. So that is cubing root of 4 divided by 3. Okay. All right. So now we found equilibrium prices, then what it can do, because now we know, going back to previous note. All right. Because a W1 turns out to be equal to W2. So a sub 1, sorry, let me start with a sub 1 1. So a sub 1 1 is cubing root of 2, because w1, w2 will be cancelled. And a sub 2 1 is 1 over cubing root of 4. Right? And you can find the a sub 1 2 and a sub 2 2 this way. All right? Then let me draw the edge of the box in the next page. Okay? So edge of the box right here. Okay? This is a O1. This is O2. And the length of this box is total endowment of factor 1, height, total endowment of factor 2. Okay? Then a sub 2 1. So a sub 2 1 over a sub 1 1 at equilibrium input prices is 1/2, meaning that from 1 we'll choose one factor. So from 1 we'll choose factor demand function. So pair of these two factors are on this ray. Okay, so the slope is given by 1/2. Okay, because this vertical axis is a sub 2 1, so z sub 2 1, and horizontal axis is g sub 2, z sub 1 1. Okay, so this ratio stands for the slope of this ray from the origin. All right, and at that equilibrium input prices, a sub 1 2 over a sub 2 2, that is, this is a sub 2 2 over a sub, that is also 1/2. Okay, so now think about the ray from origin to O. So, okay, and the slope is also 1 over 2, because with this axis, so reading this horizontal axis and vertical axis, okay, and slope of this ray is gonna be this ratio. Okay, so we have a one intersection right here, right? So we can say z sub 2 1 over z sub 1 1 at the equilibrium is equal to 1/2. Right? Following this ray, the equilibrium allocation from 1 should be on this ray. Okay, that is this condition. What this condition tells us. And from 2, equilibrium allocation must be on this ray. Okay, in other words, z sub 1 2 over z sub 2 2 should be equal to 1/2 as well. All right, and the market clearing condition on z sub 1 1, demand by from 1, and demand for factor 1 by from 2, z sub 1 2 should be total endowment of factor 1, and z sub 2 1 star plus z sub 2 2 star is total endowment of factor 2. Okay, so we have 4 equations and 4 unknowns, so we can identify all factor allocations. So it turns out that z sub 1 1 star is for z1 bar, 2 z2 bar, 2 1 star is 2 z1 bar, z2, and from 2, is z1, and 2 star is all right, and input prices W1 star and W2 star is what was that? It's a cubic of 4 divided by 3. This laptop is going to be seems likely, to explode. Yeah. All right. So because I'm using software OBS, called the OBS. I think this is a standard program for every YouTuber, but it takes so much CPU. So I have to I have to purchase a desktop to resolve this CPU issue. But the problem is, university does not give me, research fund yet. It's still in process. Anyway, yeah. So these are equilibrium. Okay. All right. So I think this summarizes. So how this economy operates at an equilibrium, and I think you can easily check that. This factor allocation. So this point is on the Pareto set. So the way to find the Pareto set is the same as the way to find Pareto set in a pure exchange economy. So now using MRTS, the slope of the isoquant, okay, we can find from one's MRTS, from two's MRTS. That is right here, because this is a marginal product of factor 1 and marginal product of factor 2 for firm 1. So its ratio, that is right here. This is a MRTS for firm 1. Okay? You can identify MRTS for firm 2 and set them equal to each other, because two isoquants must be tangent to each other at Pareto efficient allocation. So you can identify the equation of Pareto set. And in this economy, the Pareto set will be below. So let me draw the diagonal first. Okay, the Pareto set will be below this diagonal. Okay, and this point should be on the Pareto set. All right, you can easily check that as well. All right, and let me just mention one more thing about this economy. That is a factor price equalization theorem. So remember, input prices are determined by these two conditions only. Okay? And suppose our model describes one country's production, and think about another 2x2 production economy. Okay? And that describes another country. Okay? And just compare, South Korea and Japan, or South Korea and say Norway. All right. And of course, two countries have different total endowments. The population of South Korea amounts to 50,000, so 50 million, but in Norway, population just 5 million. Okay, and the amount of capital also different. But if two countries produce same good at the same output price, due to free trade in commodities, right? So the world price is given by, also the world price is the same in those two countries. And suppose two countries share the same technology, right? Then we can draw a remarkable conclusion from these two equilibrium conditions. That is, factor prices in two countries are equalized. Okay, because it does not depend. The only difference between these two countries is, suppose, the only difference is, total endowment of, each factor, labor and capital, and still does not affect input prices. Okay, and intuitively, the price of wage, so the price of labor income, the price of labor force, that is wage, and the price of capital depends on a total endowment. If we have a huge amount of capital or huge amount of a labor, say population in South Korea. Think about population in South Korea comparing with Norway, it seems like a wage should be higher in Norway, right? Because labor force is very scarce. That resource is very scarce in Norway compared to South Korea. But still, if two countries produce the same good at the same upper price with the same technology, then factor price must be equal to each other. So without the need for factor mobility, so even though some portion of population in South Korea migrates to Norway, so even that situation, two input prices are equal to each other. This is known as the factor price equalization theorem. So what is the effect of total endowment that affects only, to this problem? So which production each economy specializes in? Think about, comparing these two economies. So one economy has, a lot of factor 2 and a small size of factor 1. Okay, so the edge of the box looks like this rectangle. And the other country has a lot of labor, but small capital. Okay, and still, the factor price is the same. Okay, but the size of endowment only determines which production each country specializes in. So in this country, a lot of factors are allocated to production 2. Okay, but in this economy, most factor allocated to production 1. Okay, so the size of total endowment only affects the specialization, but it does not affect input prices. That, of course, that depends on, so this theorem depends on several assumptions. So the same technology and same good and same price, but still it can be used as a useful reference. So this is as far as I know, this is one of the fundamental theorem in international trade. So we can obtain such an insight from this model. And let me stop the second video here. And we are going to do one more exercise in this economy that gives us 2 important theorems, Stopper-Samuelson theorem and Ripczynski theorem. And let me explain those 2 in the next video.